we'll put chapter 1 in, or I'm sorry, 2 and 3 together. Regression. So we want to talk first about response and explanatory variables. The response measures the outcome of a study. And it's simply the y, or the dependent variable. The explanatory may help predict or explain changes in the response variable. Explanatory variable, get an L in there. Key word there, may. May. So it's the x, or independent variable. So up to this point, we've just been dealing with univariate data, single variable. Now we're going to be looking at bivariate data, two-variable data. I got a question for you here. Shopping for diamonds what would be the explanatory and the response in relation to carrots and money? Which one do you think, Quinn?
So would carrots be explanatory? More carrots, the more likely amount?
I believe you're right. The larger the carrot size, the more money, generally, for a diamond. I'm not a diamond expert. I know there's a whole lot more to it than that, but yeah, I think carrots would be your explanatory. Because they generally, as I understand, define size, and then your money would be your response. So this is your X and your Y. How about this? How about your math SAT score, and your English SAT score. Which one should be your explanatory and which one should be your response here? Matt, what do you think?
English is the explanatory. And without the English,
Okay. Without the English, the math becomes impossible, right? Okay. Quinn, you got a thought on that?
are they related at all? Are we assuming that they are actually related?
Ooh.
Or are they just two separate entities?
I guess the question here is, does it really matter which one is your explanatory and which one is your response? Yeah, sometimes you can blend it. I agree with what Matt said. I think without the English skills, the math is going to be pretty tough, right? It's probably the only subject that you really have to know before you can do the math. But in this case, either could be the explanatory. It really wouldn't matter. They certainly have a relationship, but one doesn't necessarily lead the other specifically. It could go either way. And your graph would probably not change drastically either way. Okay, so what are we talking about when we're graphing these two different variables? We're talking about what we get is we get scatter plots. Scatter plots are our next big graph, and they show a relationship between two quantitative variables. Measured on the same individuals. And each individual is a point on the graph. Call these, this is a bivariate data or two variable data. And we can get a number of different scenarios to come up with bivariate data. The first one we can talk about is positive association. With a positive association, the data trends up. So let's say I have a scatter plot and some data on it. Maybe it does something like this. And it's just in general going in a upward direction. And have you ever been asked about a line of best fit at any point? I was shaking So at the very beginning, I titled this regression. This would be my best sketch of a line of regression. A line of regression can be thought of as a line of best fit. Okay. Line of best fit. So most of the points fall somewhere near it. It's the average of all, and we'll talk about that calculation on another day. But line of regression is a big deal. We're going to learn it now, but it'll come back again when we're at the end of the book, actually. So, okay. So what other things could happen with this data? We can have a positive association. We can have a negative association. What else could happen with a scatter plot? Yeah. No association. That's exactly right. No association. This is a true scatter. The data's everywhere. There's no defined direction to it at all. It's just all over. So what are we looking for in a scatter plot? We're looking for direction. Is the direction positive, negative, or none? No association. Essentially zero. Okay. What's the form? Is it linear or something else? Nonlinear. We want that. We want it to be linear. But if it's not, it's not. What do we do? The next thing is strength. Do the points line up pretty closely, or are they really pretty scattered out and yet still show some sort of relationship? Is the relationship weak, moderate, or strong? And the last thing we want to look at, maybe make note of, are there any unusual features? What might be an unusual feature? Yeah, we could have an outlier, right? For sure. Outliers we always want to mention, or suspected outliers, right? The other thing that could happen is maybe we have a bunch of data clumped up in one area. Some sort of like clumping or gathering, clustering. Any clustering or outliers? We would want to make note of that if we were answering a question about it. Okay. How do we decide weakness, moderate, or strength? We have something called correlation. Correlation is our R value. And it measures the direction and strength of the association between two quantitative variables. Measures the direction and strength of two quantitative variables. It does it this way. Correlation can be anything from -1 to 1. Negative values indicate a downtrending relationship. It doesn't give slope, but it's negative is trending down, or your negative association. Your positives trend up. The closer you are to -1 or +1 is the better, the more linear a situation is. Okay? So the points line up almost perfectly at -1 or 1. What do you think 0 is going to be? It's not negative, it's not positive. It's a good thought. No? Yeah? Another thought? No association, right. 0 would be no association. It's a true scatter. So your true scatter, so this one would be, let me go back up here. This one would be R is negative. This would be R equals 0. And the first one would be R is positive. And how close to 1 it is how tightly gathered the values are. We'll look at that here in a little bit. Hi. Okay. All right. Something to remember. We've mentioned this before, but it definitely comes into play now. Correlation does not suggest causation. Very early on in this class, I mentioned something that'll come up again and again. Hot dogs and lung cancer, right? There is a correlation between hot dogs, how many hot dogs you eat, and what's your likelihood of getting lung cancer. But that does not suggest that the hot dogs cause the lung cancer, right? It's a good thing, too, because I sure love me a good Costco dog. Right? Hot dog and a soda for $1.50. And you can put all the onions and junk on it that you want. It's awesome, right? You guys know what I'm talking about. Yeah? The pizza's not too bad either for the price. The only bummer is they've discontinued the Polish dog. That was my favorite, but the crazy thing about that was it was $1.50 when I was your age. It hasn't changed in 30 years. So I know they're losing money on that. Anyway, all right, moving on. The formula. Let's look at the formula. The formula for R. For our correlation. equals 1 over n minus 1 times x1 minus x bar over s sub x, the standard deviation of x. Now we have two data points now. We've got x's and y's, so I've got to multiply that times y1 minus y bar, so that's going to be the average of the y's, over s sub y, the standard deviation of just the y's. And I add that over and over again until I get to x sub I plus x bar, I have to kind of cram this in I think, over sx times y sub I minus y bar over s sub y. Imagine doing that for a sample size of 100. Not too much fun, right? The shorter version of this uses this sum symbol, and it's x sub I minus x bar over sx times y sub I minus y bar over sy. So the sum of all of them multiplied together like that. That would be a good time with a with a regular calculator. Could you imagine doing all that work with by hand? So you'd have first of all to find the averages, and then you'd have to find the standard deviations, and then you'd have to put it all together. And if you made a mistake, it would suck, right? So what we have at our disposal, fortunately, is the ability to do it with the calculator. On page 159, I want to look at a problem. So let's do this one together. Let's see. I'll put the data up here for us to put into our calculators. So we're comparing a couple of my favorite things here. Sugar and calories. So if you'll put the sugar into one list, one long list, and the corresponding calories in the other. Now you don't want to what do I want to say? It's Friday, I can't talk. I don't know what I'm trying to say. You don't want to sort these. You want these values to be in relation to one another. So the 45 goes with the 450 and so forth. But if you'll put those in, that would be excellent. I wonder how Snickers fits into here. I should have got a Snickers bar this morning and brought it in and thrown it into the list. Because they always say it really satisfies and it has the peanuts and everything. The peanut M&Ms have about 1 million calories, but not so much on the sugar in comparison to some of the others. I wonder how Snickers would look. I should look it up. All right. So we have to make an adjustment on the calculators too. The To get the R value, you have to have your stats diagnostics turned on. And I'm thinking probably most of my calculators that's already been done, but we need to check it. So if you would please go to mode. If you have your own calculator, it's probably off. It defaults to off. And go down to stat diagnostics, and you want to make sure that that is turned on. Otherwise, you will not get the correlation values that you want. Does anybody have one of the older calculators that doesn't have this? Probably get you an update. Anybody else have one of the older ones that doesn't have that in the manual? No? Okay. All right. So let's graph our plot. So what you want to do is you want to go into your plot one, make sure everything else is off. The first one is your scatter plot here, and you want your X and your Y to be represented correctly. We'll make the sugar the X and the calories the Y. That seems to make the most sense. And then we'll graph that. Oops, hang on. Let me get rid of something here. Now you'll probably have to zoom 9 to get this view. And if you've got the line, let's get rid of it. Go to just y equals and delete anything in there. All right. So when you're doing scatter plots in your assignments and stuff like that, just a quick sketch is just fine. Where did my note page go here? So here's what we're going to do. So to find R, and graph, by the way, anybody want to make a guess? Is R going to be positive or negative? Positive. Do you think it's pretty scattered? Is the number going to be closer to 0 or closer to 1? What do you think? Any guesses on that? Like maybe halfway between? You think like a 0.5, maybe 0.6, something like that? Okay. We'll see here in just a bit. So in the calculator, you want to go to Stat, and then Calc. And there's 2 line of regression choices. We want line reg, I think it's number 8, a plus bx. So if you go into that, stat, calc, there's actually two line regression equation choices. The first one says ax plus b, and the second one says a plus bx. Now, it's a linear model. Okay, they're trying to make a linear model here for it. This is line of regression. So ax plus b actually, to me, makes more sense. It's your mx plus b, the a being the slope. But for some reason, statisticians have to do things differently, and most books and most problems will introduce it this way, where the y-intercept is given first and then the slope. So a is the y-intercept and b is the slope. Since that's the way our book does it, and most of the time that's how you'll see it, we'll choose this method. So we've got our x list 1 and our y list 2. Frequency, we always leave that one just alone. Store the regression equation, though. You want to do that. Maybe not every time, but you want to do that. So what it does is it stores it so that it'll graph the line for you. It stores that information. So to do that, we're going to go to vars. I'll write this down here in just a little bit. So vars, yvars, function, and then you choose where you want to put that line into the calculator. So y1 would be just fine, I think, probably. And then calculate. So this is telling you the form of the function. Here's your y-intercept. This is your slope. R squared, we'll talk about R squared coming up. Here's our R value. You guys are pretty close, about halfway, about 0.6162, about 0.62. So to graph the line, we're going to go to vars, then yvars, and then into wherever you want it to be, L or Y1, not L1, Y1, and then calculate. So let's have a quick peek at that guy. Now go back to your graph. You should have